guys, Felipe here. So as you know, I'm here to keep you up to date with market news, teachings, and everything tech. That way we can learn this stuff better together. So in this video, I'm going to be talking about Quicksort, which is one of these sorting algorithms. Let me jump right ahead into that. So it's very similar to merge sort in the sense that it basically chooses a pivot, right? And then depending on that pivot, it then breaks all the elements inside of the list into categories, to smaller piles, right? So here in this snippet, the pivot is a little red column there, and then everything that is smaller than that pivot gets allocated to the left. Everything that's larger gets allocated to the right into sublists, right? And then it gets recursively sorted from there on until the final output is a fully sorted list. So here's another example. Basically, you got a bigger unsorted list on the very top there. The last element is typically what is chosen as the pivot. And then from that pivot, everything that is smaller gets allocated to a left array, and everything that's larger gets allocated to a right array. And then it gets broken down further and sorted in that manner, right? So that's basically how it works. So Quicksort is one of the most useful and powerful sorting algorithms, and it is not too hard to understand. It's another divide and conquer recursive algorithm, but it takes a slightly different approach. Basically, you take the last element of the array and call that the pivot. Everything that's smaller than the pivot gets put into the left array. Everything that's greater than the pivot gets put into the right array. You then call Quicksort on the left and right arrays independently via recursion. After those two sorts come back, you can concatenate the left array, the pivot, and the right array in that particular order, right? And the base case, of course, which ends the recursive calls, is basically when you have an array that is of length 0 or 1. So here's an analogy. Let me know if this stuff helps. It made a lot of sense to me. So imagine you have a messy pile of books and you want to sort them by size, right? Quicksort is a way to do this efficiently. First, you would pick a book, right? Pick a book out of the pile. You would call that book the pivot. Divide the pile, right? Then you make two new piles, one for books that are smaller than the book that you chose as the pivot, and another one that is bigger than the book that you chose as the pivot, right? So the bigger books on the right of the pivot, the smaller books on the left of the pivot. Then sort to smaller piles. Now pretend each of these smaller piles is a new messy pile of books. You can use Quicksort again on these piles to sort them further. This is the recursive part. And then you combine, right? Once everything is sorted, you simply put the piles together in order of small books, the pivot, and the big books, right? In that particular order. Stop if it's small, right? If you ever end up with just one book or no books at all, then by definition, it's already sorted, right? So it's a divide and conquer strategy to sort things piece by piece. So that's an analogy there. Big O, what is the big O? The worst case scenario is a sorted list. The pivot will always be the largest number in the array because it's already sorted. So it's going to be the last one, meaning that the left array will always be full and the right array will always be empty. In order for us to get that log n magic, just instead of n, right? We need to be able to skip some comparisons. If it's sorted, we will compare every number against every other. So we end up with that log, with that O n square, right? Same would apply with a reverse sorted array because everything gets compared basically. Best case scenario is actually the same as the average case, which is a randomly sorted array. In this case, the pivot will be approximately in the middle, so you would get a good mix in the left and right arrays, which produces log n performance. In these cases, it will be O n log n, which is great. Spatial complexity, you can implement Quicksort as a destructive sort that operates in place and uses some other tricks like tail call optimization. In that case, its spatial complexity will be O log n, because it will still make memory allocations on the stack, on the call stack. Variations, all the variations are basically around the pivot, where the pivot placement is, right? So that's what different kinds of variations of quicksort that can be written. Before I jump into putting quicksort together, this quote's pretty cool. A student asked the programmer of Ode, use only simple machines and no programming language, yet they made beautiful programs. Why do we use complicated machines and programming languages? Fusio replied, the builders of the Ode only use sticks and clay, yet they made beautiful huts. Pretty cool quote. So let's go ahead and jump into the editor and let's get busy. So to get this started, just gonna make a folder called quick sorts, and we're gonna go into that folder, quick sorts, which I misspelled. So cd quick sorts. There we go, beautiful. And we're gonna just have one file in here, which we'll call quicksorts.js, and we're gonna do that npm init -y to not answer all those questions and jump right into the editor, right? So what we're gonna do here is basically we're gonna have a function, and we're gonna call it quick sorts because that's what it is, and I always capitalize that up. And we're gonna pass in a list or an array of some sort, right? So that's what's gonna get passed into this function that is gonna sort that that array, right? So the base case is basically when the array is length 0 or 1. So array of length 0 or 1 is the base case. So it's already sorted. So basically if num's length is less than or equal to 1, we're gonna return it because it's already basically sorted, right? Now we're gonna split it up, right? We're gonna partition everything and make the last, well, actually, we're gonna make the last number is the pivot, right? The last number in the list or the array is gonna be the pivot. So const pivot equals nums dot length -1, which is the last element in that list. And for the left list, it's just going to be an empty array, and for the right list, it's just going to be another empty array, so we can allocate things into there depending on the pivot, right? So next we're going to sort all smaller numbers than the pivots into left array, and all bigger numbers into the right array. And to do this, we're going to use a for loop to loop through all the elements inside of the list. So as long as I is less than nums length -1, we're going to increment I. And now if nums I is less than the pivot, it's less than the pivot, right? Then we're going to allocate that element into the left list, right? So left.push nums that element into the left list, right? Otherwise, right.push nums current elements into the right list, right? Beautiful. So that is basically what does all the partitioning there. It iterates through all the elements in the list. And if the element is smaller than the pivot that we allocated in the top, it gets pushed to the left list. And if it's larger, it gets put into the right list, right? And then finally, we're gonna basically call quick sort on left and right independently, right? And concats all into one big array with pivots in the middle. And then we just return. So this is what we're gonna do here. We're gonna return quick sort left dot concat pivots, and then quick sort right. And boom. So we're quick sorting the left. And then we're concatenating it with the pivot, the left with the pivot and the right. That's basically what we're doing. So now to see if this actually works, we're gonna do a const r equals 8, 6, 5, 4, 9, 7, 3, 2. And we're gonna give that, we're gonna feed that variable right there, that array, console.log to the quicksort function. And that does all the magic, right? So quicksorts are boom, boom, boom. And sweet. Now we're just gonna run it, node quick sort JS, and it spits out a sorted array, right? So that's basically the whole point. Gets an unsorted list, breaks it, picks it, chooses a pivot, allocates things smaller in that pivot to the left list, allocates larger things to that, then that pivot to the right list, then it concats everything together from left to pivot, and then middle right in that particular order. So cool. If you like what I shared with you and would like to hear more, stay tuned for more videos in this series. And with that being said, thank you guys for watching. I'll talk to you guys on the next one.